Have you ever just looked at an AI and wondered, how does it do that? How can it possibly look at a picture and know what's in it? Write a caption, like it actually has eyes and a brain? Well, today we're going to pull back the curtain on an amazing model called PaliGemma and find out exactly how the magic trick works.
So let's just start with this. To us, it's a super simple drawing of a car. But you feed this to an AI, and almost instantly it spits out the words, a photo of a car. I mean, how? Is it actually thinking? Is it seeing? What is really happening under the hood to make that possible?
Well, here's the secret. It's not one single, giant, all-powerful AI brain doing everything. Nope. The real genius here is in the architecture. It's actually a team of two highly specialized AI models, and they're working together, each one a master of its own job.
Okay, so let's get into it. Let's unpack this architecture. We're going to meet the whole team, see exactly what each member does, and figure out how in the world they collaborate to turn simple pixels into actual words.
All right, first up on the team, we've got what the code calls the VisionModel, or the Vision Tower. You can think of this as the eyes of the whole operation. Its one and only job is to look at the image. That's it. It doesn't know words, it doesn't know grammar, it just sees pixels and patterns. It is the silent observer.
And its partner? That's the language model. Now this is a powerhouse. It's the kind of AI you find in chatbots. It's an expert in language, grammar, concepts, ideas, but, and this is the key, it's completely blind. It has no idea what an image is. It's the eloquent voice of the operation.
And that right there brings us to the biggest question, right? You've got the eyes that speak the language of pixels, grids of numbers, and you've got the voice that speaks the language of words and meaning. They literally speak different languages. So how on earth do they talk to each other?
And the code gives us this absolutely brilliant solution. There's a third component that acts like a bridge between them. It's called the Projector, and its only job is to be a universal translator. It takes all that numerical data from the eyes and transforms it into a language that the voice can finally understand.
Now, what's so cool about this is that this isn't just a convenient analogy I'm making up. If you actually look at the main PGemmaModel class in the source code, you'll see it laid out plain as day. It defines Vision Tower, Language Model, and Multimodal Projector. The code itself is literally built around this amazing little team. So, we've met the team, the eyes, the voice, and the bridge that connects them. Awesome. Now let's zoom in on that very first step. How do the eyes, that Vision Tower, how does it actually process a picture? How does it turn a simple JPG file into something an AI can work with?
The whole thing really starts with this core AI concept called embeddings. And that might sound complicated, but it's really just a fancy word for translation. We're translating the image from a language we get, pixels, colors, shapes, into the one and only language the AI understands, a perfectly organized list of numbers.
And this is exactly how it does it, and it's laid out right in the VisionEmbeddings code. First, the AI slices the image into a grid, kind of like cutting a photo into a bunch of tiny little square tiles. Then it takes each one of those little patches and turns it into its own list of numbers. And finally, and this is clever, it adds a sort of digital GPS tag to each list, so it always knows which patch came from the top left versus the bottom right. So, what you get at the end is this, a numerical jigsaw puzzle. The AI never sees a car the way you and I do. What it gets is this incredibly organized mathematical representation of the car, where all the pieces and their exact locations are perfectly preserved in number form.
Okay, so the AI has its numerical jigsaw puzzle. It can see the car as a big pile of data. But now what? How does it think about this data to build a sentence? I mean, it can't just look at all the puzzle pieces at once and make sense of it. It needs to focus.
And the breakthrough that makes this possible is a mechanism that was famously called attention. And it's exactly what it sounds like. Just like you focus your attention on the most important parts of a scene, the AI uses a mathematical version of this to figure out which pieces of the image data are the most important for the job it's trying to do.
A really great way to get this is to think about searching in a library. The query is the question the AI is asking itself, like, what's the main object here? The keys are like the titles of every single book in the library, in our case, every single patch of the image. The AI compares its question to all the keys to find the best matches, and then it pulls the values, the actual good stuff, the content, from the most relevant patches.
And yep, you guessed it, this is written right into the code. The attention class has these little tools called QProj, KProj, and VProj, which stand for query, key, and value projections.
This is the math that lets the AI ask what's important here and focus all of its processing power on the puzzle pieces that show the wheels and the windows, while basically ignoring the boring, empty background.
So this is it, the final step. How do we bring this all home? We've got the vision data as a puzzle, we've got the attention mechanism to focus on the important pieces, and we have the language model ready and waiting to talk. Let's see how the final caption actually gets assembled.
And the last bit of the code shows us this really elegant loop. First, the image data and a starting prompt, maybe something simple like caption, get processed. Then, a function merges them together into one big package. The language model looks at that package and predicts just one thing, the single most likely next word. Then, that new word gets added to the input, and the whole thing loops again to predict the next word and the next, and so on.
And that's how the magic really happens. It doesn't come up with the whole sentence at once. It builds it, one word at a time. It predicts then it feeds that back in and predicts photo, then feeds that in and predicts of, building the description piece by tiny piece until it's done.
So what felt like a complete magic trick at the beginning turns out to be this beautiful, really logical system. You've got the eyes to see, the voice to speak, the bridge to connect them, and this brilliant little loop that puts it all together, one word at a time. It's not magic at all. It's just really, really clever engineering.
Think about it. This technology, this ability to connect what we see with language, it's unbelievably powerful. It opens up doors for everything from helping the visually impaired navigate the world to building robots that can actually understand their surroundings. So the question isn't just about how it works anymore. It's, now that we know how to do this, what are we going to do with it? What's the next big thing we should teach it to do?